Okay, so let's start. So the topic for this video is potentials. Okay, so far what we have learned is, for a given system we have a governing differential equation which is given in this form, right? And for this equation we could solve it analytically, which will provide me x as a function of t, but sometimes it will provide me only the relation between x and t. Okay, so in order to understand this system qualitatively, if not quantitatively, we used a graphical approach, right? In the graphical approach, what we do is we make a plot between x and x dot, and from that plot we will try to understand how the system is going to behave, right? And today's topic we're gonna use a graphical approach, but which is going to be slightly different from this one. Okay, and in that graphical approach what we're going to do is we are going to introduce something called potential, which is denoted as V. Okay, which is denoted as V. The way it's being defined is in the following manner. So d dou V by dou x minus of dou V by dou x is equal to f of x. So that's how we define the potential V. Okay, now for a given V, okay, once we identify V using this equation, what we're gonna do, we are going to plot x versus V, and we will try to understand how the system is going to behave. Okay, so in order to understand, I want to let you guys know few relation. Let's say as time progress, what will happen to this potential V? Okay, let's try to understand. So what will happen as time progress, that we will get to know once we know what is V dot, right? So V dot is equal to dou V by dou x into x dot. Okay, I can write it like that. Fine. So what is dou V by dou x? From this relation I can say that is minus f of x, right? And what is x dot? From this I could say that is f of x, right? So this f of x into f of x is always going to be positive, if not 0, right? And the negative of that will always be less than or equal to 0. Okay, it will be either negative or 0, V dot. Okay, so if I make this plot, let's say this is my x, this is my V. Okay, and let's say I am getting an equation like this. Okay, and now let's say this is my x at some particular time t. Okay, now so this is the x value. Will this x go in this direction or this direction? Because that's the only directions it could go, because it's a 1D flow, right? So will it go in this direction or this direction, which means will the x going to increase or decrease? So that we could identify from this relation. Okay, so it will choose a direction such that V dot will be negative, which means it will choose a direction such that V will decrease. So from that I could say if it goes in this direction, then we will decrease, so it will have a flow in this direction if it is at this point. Okay, okay, now when will it be 0? Okay, v dot at some point will be 0. One second. Okay, so the v dot will be 0 if and only if f of x is 0. Okay, what if f of x is 0? If f of x is 0, x dot is 0. Okay, which means that point is a fixed point, right? So v dot will be 0 at fixed points. Okay, but also we know that dou v by dou x is equal to minus f of x, right? So okay, what is dou v by dou x? Dou v by dou x is nothing but for a given x value, the tangent of that curve on that x value is f of x, right? So if v dot is 0, then f of x is 0, which means the slope of this curve is 0. So that's the point where we obtain our fixed points. Okay, so one is this point. Okay, so that's a fixed point. So another one is this point. Okay, that's another fixed point. Now among these fixed points, we need to classify. So one is a stable fixed point and another one is unstable fixed point. So among this, which is stable and which is unstable? Okay, if from this point, if I give a little disturbance, what will happen? It will try to decrease the v value, right? So it will go in this direction, and similarly if I give a little disturbance in this direction, it will go like this, right? So this is a unstable fixed point. This is unstable. Okay, what about this? If I give a little disturbance, okay, it will come back to the equilibrium point, and the same goes for the other direction as well, right? So this is stable fixed point. So that's how we identify the behavior of the system. So all we have to do is identify the potential, plot it. Okay, the peaks and valleys are the fixed point, where the peaks are unstable fixed point and the valleys are stable fixed point. Okay, fine. Now let's see an example. Okay, let me take the example from the book, which is this. Okay, x dot is equal to minus x. Okay, so for this case, what is my v? So from this definition, so all I have to do is integrate this part, and I will get v is equal to half x square plus some constant, right? And now if you see in this analysis, all I care is whether where is the peak and where is the valley, right? By adding the c, all it does is just a shift, okay, either upward or downward. So by that shift this point is not going to change, or any of the character is not going to change, so it doesn't matter what the C value is. So for the sake of easiness, I am going to ignore the C by putting that as 0. So finally the answer I will get is just x square. Okay, so V is just half x square. Okay, now let's plot this function. Okay, okay, if I plot first let me plot minus f of x. Okay, so that's x dot versus x, or f of x versus x versus f of x. Okay, so this intersects at this point. Okay, so that's our fixed point. Okay, and what kind of fixed point that is? At this point x dot is positive, so it will go towards the fixed point, and here the x dot is negative, so it will go towards the fixed point again. So this is a stable fixed point. Okay, now let's plot x versus v, so which is 0.5 into x square. Okay, I hide this one. Okay, so if you see, this is the curve we have got, and it has only one extreme value, which is this one, and this is the lowest point, right? So therefore it is a stable fixed point, so we have obtained the same result. Okay, so that's how we use potentials in order to understand about the system. Okay, and in this book I want you guys to attempt to solve this, or go through this example. This is the system differential equation. For this you need to calculate the potential, and try to plot the potential, and try to understand whether you are getting correct result or not. Okay, so that's all about the potentials. And now okay, the next topic is solving equations on the computer, and this part we are not going to we are going to omit. Okay, and I'm going to leave that as a reading assignment. Okay, and that's the last topic of this this chapter. So with that we have completed this chapter, and in the next video we'll discuss about the next chapter. Okay, thank you.